Alright, hey everybody, welcome to the UQCS event. I'm Tom Malcolm stand-in. I'm also last year's president. Tonight we have an introduction to continuous integration and delivery by Paul Clarke. Paul is a legendary figure in UQCS, so take it away.
Right, thanks for that, Jimmy. So hello everyone. If you don't know me already, hi. I'm Paul. So pretty much a couple of fun facts about me. I was on the committee for 2 years, from 2020 to 2021. I was on the workshops team and the content creation team, did a couple of fun things for that. I'm a black belt, and if you've been to one of our UQCS hackathons, I'm the person who goes and spends an inordinate amount of time trying to organize a band for that hackathon to play at. And that is exceptionally fun, so you should come along and hear us play sometime. But what you're here tonight to see is an introduction to continuous integration and delivery, an essential thing which is going to help you in almost all of your projects. So I like to start with this. So how do we stop this from happening? One person deleted his entire company with one line of bad code, right? Now, sure, he could have tested it, but he didn't. So one could argue, why don't we just automate this? And so that's what continuous integration is all about. So what this talk is pretty much going to be covering. So we're going to be looking at what is CI, continuous integration, what is CD, continuous deployment, how it ties all in with continuous delivery, and we're going to chuck in a couple of examples and how does it work and whatnot. And also for the duration of this talk, I'll assume you know a bit about GitHub and version control, because those are very important when it comes to all this CI and CD stuff. And in terms of the actual examples, I'll be using something called Github Actions to kind of explain how things are working here and there, and I'll also explain some other alternatives as well at one point. So let's get into it. Continuous integration. So this is the definition that Atlassian has on their website. Just pretty much, continuous integration is the practice of automating the integration of code changes from multiple contributors into a single software project. That is a very wordy definition, and frankly, it doesn't mean a lot. So I'm going to explain it in a much simpler sense, I hope at the very least. So this is also a graphic from Amazon this time. So 3 things that you can really achieve well with CI. It improves developer productivity, you can find and address bugs quickly, and you deliver updates faster. So the whole point of continuous integration is that as you're developing and you're pushing changes through your version control, you have your continuous integration, which is continuously checking that you haven't gone and stuffed up somewhere and, for example, added a line of code that's going to destroy the entire business, right? So it's these sort of things which is going to improve developer productivity, okay? And if you do make a mistake somewhere along the line, you'll be able to find it because your continuous integration is going to tell you where exactly your test cases have failed and whatnot. And I'll link more into that as well once we get into some examples. And delivering updates faster also kind of links into the whole idea of continuous deployment and delivery, because down the line, once you have a foundation of continuous integration, then what you want is just to be able to make pushes and make pull requests and changes to your code base and have that automatically deployed to your customers. That overall is the end goal. So I'm going to start off with a little bit of a case example, which is of any sort of organization here with 4 completely random names. So we have Tom, Jimmy, Matt, and Nick. Now, these 4 people are all contributing to a code base, okay? Now, they could all be contributing different sorts of projects. Maybe Tom could be contributing a really small change, a small bug fix or something. It might take him possibly, let's say, an hour or 2. That's pretty simple, and it shouldn't have too many lasting changes. But let's say, for example, Jimmy here is working on a big project that could be maybe a week or 2 weeks, okay? Imagine the number of changes that is going through the code base, okay? If you think about it, there could be many points of failure all at once, okay? And if Jimmy here is contributing all that all at once to the code base and many things have gone wrong, then what Jimmy is going to have to do is going to have to go back and fix things constantly. And they're going to have to go back to the start and fix one bug, which might lead them to another bug, which might lead them to another. And suddenly, you're now wasting time going back and fixing bugs when these could have been pointed out to you way earlier. So, how can continuous integration help? Well, imagine each purple square here is a push to your version control, okay? At every single push, your continuous integration is going to go through your changes and is going to check, hey, are these passing the tests? Are these going to work? And if they're not, then you'll know at that point. That's going to save you from going all the way back later down the line, and you're going to be able to fix things when they happen. So, for example, I mentioned earlier, Tom here, say he had a small change, right? He has one CI that comes through, okay? That's going to be something simple, it's going to pass, then that's going to go straight to the code base. Say Jimmy here, he's now going to work and do 2 pushes to the code base. The continuous integration is going to run twice, and he's going to know if something fails at this point, he can come back and fix it. And then it's going to check again at the last push, and then pretty much deploying then is going to be a whole lot simpler. So, I've made a small little repository, which is going to be a little bit of an example. So, I'm going to first start by launching my VS Code. So, this here is a small little class I've made.
You make it bigger.
Yes, I can. Is that in the...
You can use Command Plus. Yeah, Command Plus.
Command Plus?
Yeah.
Ah, thank you. Okay, great. So, in here I've made a class called UQCS Talk. And here it's pretty much initialized with the name of the talk, number of hours, we're thinking duration of the talk. It has some getter methods, and at the end here, I've just created this small method here which is going to add an hour. And if things work, which I sure hope they do, it's going to return true, okay? And pretty much our testing is going to make sure that this is going to work. So I've also made some other kind of random tests here to make sure things are okay. Some random addition tests. But the main idea here is this testing file here, which is pretty much, this method here is just going to test that if we add an hour, then the hours in our class actually go up. So, once we have this, we want our continuous integration to run these tests automatically every single time. So, say now we have our pull request, okay? We've added our test, okay? And if we come down now to here, we have 2 little ticks. One saying, yes, we have no conflicts with the base branch, everything is okie dokie. The first one is saying, hey, all checks have passed with 1 successful check. And if we check on the details, it says, hey, this PyTest has passed. So, it's automatically gone and tested all of our test cases against our new changes. And if I go to the details here of this, and I go to the run test suite action, it says here 8 test cases passed in 0.03 seconds, which is exactly what we want. Now, on the other side of this, say we mess around and tests are now breaking. Then this is exactly what's going to happen. Our continuous integration is going to come through, and some of our test cases are going to fail. So, then we can click on the details and see exactly what's going wrong. So we come here, and it says, hey, we got a type error. And the reason we get that type error is we can go now to this most recent commit, which I'll take a note of here, has a red cross next to it, meaning the test case had failed. So I'll click on this, and right here it says, hey, we're now trying to compare an integer to a string, okay, which is not going to work at all. So with continuous integration, you can have these sorts of things all automated. Now, at this sort of small scale, when you have 1 or 2 tests, it doesn't really pay off too much to use it. But say, for example, you work in an organization or a massive corporation that has 100, 1,000 tests, okay? Something really large. Then it's not going to really pay off to run those tests locally. So what's going to happen is some person's going to push their changes through, and then your continuous integration for that business is just going to run all those tests from all those different teams. And that way, you're going to speed up the process of which you can push out changes to your customers through your app, really. So, coming back to here. This here is pretty much what's happening when I'm running my tests, okay? So this here is called a workflow, and it pretty much runs the tests. So, firstly, up here, we have the on push. This is a workflow trigger event, okay? So pretty much this workflow is triggered by a certain event, and in this case, it's triggered by the push event. Now, you can also have a bunch of other different events here. You can have a fork, a pull request, delete. You can have it when a new issue is created or a new comment is made. This is only a limited example. There are also many other different events you can use. I just have this one here because I want it so when I push a change, it checks the tests. Next up, the jobs. So pretty much, the workflow has a bunch of jobs it has to run, and each job has a set of steps. Now when you run a workflow, it's actually creating its own virtual environment, and you're designating what that virtual environment is actually going to look like. So for example, up here, we're running the virtual environment on the kind of Ubuntu latest sort of VM. And coming down here, we're actually setting up Python and installing the dependencies. So that way we can actually run our tests later on. Now, workflows run using actions, and actions are kind of reusable pieces of code that do a variety of different things. So the most important one is the checkout action. The checkout action, which is, I'll point the mouse at it, right here. The checkout action allows your workflow to see what's actually happening inside your code, okay? Now, your workflow won't be able to see it without this. This is almost the essential action you need. Moving down, like I said earlier, we're setting up a virtual environment. So what we have to do now is we have to set up Python. So in this case here, we can choose what Python version we want. I want Python 3.8. And this is also probably a good time to mention that there is an @v2. And this is pretty much the version of the action. And so it's pretty much a sort of update, which update you want to use for that action. Then moving down to here, we're pretty much at this point here running a bash script. And in this case, we're installing our Python dependencies, which I've put in the requirements.txt. And then at the very end here, we're just running all the tests. And at the end of that, like you saw, it's going to tell us if the test cases have passed or if the test cases have failed. And that's pretty much how that workflow works. So before I move on, does anyone have any questions? Nope. Great. So this here is another workflow example. Specifically, it works on pull request issues, and specifically when anyone comments on them. So up here, we have on issue comment. Now, this could be initially any issue comment, but we've specifically made it so that it only works on pull requests. And we've done this by using an if statement. So we can ask GitHub if this issue is actually part of a pull request, and if it is, then it decides to run the rest of the workflow. And moving down here as well, we can also set up environment variables as well. And if you don't know what environment variables are, they're sort of variables that a developer can set up, which are pretty much only be able to be seen by the developer. So if you want to store API keys or private information like that, then storing them in environment variables is really useful. So a practical example of using that is, for example, say you want to deploy to an AWS server and you have an AWS API key. You don't want to be putting that key inside your workflow, so that way people can go to the workflow and see it. What you'd want to do is put that inside the environment variable. Then moving down to here, we're just running another bash script here, which pretty much says that we're going to be printing out the issue number. And this here is, if you're familiar with it, is your friendly UQCS bot. So this one here, on the left-hand side, is pretty much all the workflows running. So you can see here that we have all these different branches running here, and the times that it takes for all these workflows to run. And as you can see, in the past month or so and all that, you can see we have all these different people making changes, and so far, everything works. So all the test cases are passing. And there is a lot in this workflow file. I only screenshotted a small part of it, but it uses environment variables and a lot of different actions. So if you're interested, you can go on over to the UQCS repository, to the Discord bot, if you're interested in seeing more and learning a little bit about it. So one really common use case of continuous integration is something called CodeCov. So if you've done CSC 2002, you've probably heard about code coverage, which is pretty much how many of your test cases are actually covering all your code. Now, it's not necessary that your code coverage has to cover all of your code, but having a high code coverage is still important. So it's a really good statistic to know when you make a change to your code base, how has your code coverage actually changed? And that's where CodeCov comes in. There exists a couple of workflows and actions that you could say, well, when I make a pull request or a push to the code base, I want you to sync up to CodeCov, send a build and the test cases off, and then what CodeCov can actually do is then come and comment on your pull request. And it can tell you how your test cases have improved coverage, or in some cases, even the coverage has gone down. And especially, for example, when you're writing test cases, it's really useful to have this sort of information. So this is one really common and really important use of CI. So far we've been using GitHub Actions for most of our continuous integration, but I thought I'd just chuck in some of these alternatives. So for example, Jenkins, Circle CI, and Travis CI. I think at one point UQCS used Jenkins. Is that still the case? Yeah. No? No? Okay.
We all switched to GitHub Actions.
Okay, sweet, yeah. So we now use GitHub Actions, but I think we did use Jenkins at one point. I think I've always used GitHub Actions. I've thought that was always fairly simple, and they have a fairly extensive Actions Marketplace as well, which I can show you. But these are some alternatives. Okay, before we move on to this, does anyone have any questions about continuous integration at all? No? Perfect. Okay, so continuous delivery / deployment. So this is a small snippet from Atlassian. So far I've covered half of this because I want to cover this first part. So continuous integration. We've already covered the building and the testing phase. So we have our test cases covering our build, and we can see if things are working or not. But where do we go from there? Where can we extend this to the point where we can automate our entire development process? That's where continuous deployment and delivery come in. So continuous deployment. What continuous deployment can do is once your builds are all passing all your test cases, then you can get to the point where all your workflows are automatically deploying your code to consumers. Now, this is going to get your changes quicker to consumers. They can see your updates really often. But there are a couple of pros and cons, which we'll come into in a second as well. Then there's also continuous delivery. And the way I like to remember this is we are continuously delivering releases to the production point. And at that point, then we can say, okay, maybe do a last manual check to see if things are working okay. And if they are, then we can say deploy to production and then do some last smoke tests to see if everything is working as needed. Now, in large organizations, they would be working towards continuous deployment, because if you have continuous deployment working and fully automated, then you can spend less time working on releases, and you can spend more time developing, which at the end of the day is what you want. So firstly, here are some of the pros and cons of continuous delivery. So firstly, I'm going to go into the cons first. So the cons of continuous delivery is that you need a very, very strong CI foundation, because at this point, you're going to be continuously delivering all your code ready to be released to the production stage. So at that stage, you have to be confident that the code is going to work. And to be confident that that code is going to work, you need to have extensive tests. So that there is probably the most time-consuming part of getting continuous delivery up working properly. But the pros of this, though, are that teams now no longer have to spend a lot of time preparing for releases, because the releases are going to be ready for them to pretty much deploy, because you've spent so much time working in test cases and automating that entire process. Now, continuous deployment. So I'm going to say this again, but your testing now needs to be absolutely perfect, because God help you if it's not and it goes to production. Because now, your code just doesn't work. If bugs go to production, then your clients are going to complain, and then it's going to have to come back to you, and then you're going to have to be spending even more time to sort it out. So you have to be confident in your tests. You have to be sure that they work. You can incorporate code coverage into it to make sure that your tests are actually covering a higher percentage enough of your code base. So your testing has to be on point. But if your testing is there, then the pros of it are that it's pretty much all automated. Your team can now focus completely on the development side of your application or whatnot. You now don't have to worry about preparing for releases or spending time working on smoke testing or whatnot, because your CI/CD pipeline is all going to automate that entire process for you. And that's probably one of the reasons why big corporations are aiming for something like this. Because in the end, if you're working to continuous delivery, you're going to be delivering to production, right? However, then you're going to have to hire staff or use staff time to pretty much get staff to, I'll rephrase that. You know what? Let's skip this point. Okay. Perfect, isn't it, huh? Love having a little brain melt halfway through. But yes. So, like I've been saying, I think the last point of this is that continuous deployment is probably where most organizations are aiming to. Okay, so I'd like to also now go into some cool little actions. So the Github Marketplace has some very cool actions that you can add in your workflows. And there's a whole variety of them, but after a quick little search, I found, I think, 4 little cool ones which will be, I think, worthwhile showing. Okay, so here's one. So Discord for GitHub Actions. So here you can say something along the lines of, okay, when a push or a pull request has been made, you can have an action which goes and posts that information to Discord, right? I'm pretty sure the UQCS bot does this now. Yes? Yeah, it does. So that's one really cool feature of it. Another one is this, profile readme stats. So with this, you could have a workflow which tracks the stats of your projects and how everything is working. And then you can incorporate some of those comments and features into your README. So that way when people come to your profile, they can see all these cool stats, which some employers might actually like. Who knows? Another one here is the YouTube videos as posts. This one's a little bit of an interesting one because you can say something along the lines of, if a YouTube video has been posted, I want to change my website. Now, what this looks like in practice is, say you have this. This is one of the demo websites on that page. So right here, these are actually all posts made from this GitHub action. So if I click on this, that's going to take me here to the PGTRB Chemistry Free Test Series. And just like that, with no input at all from the developer, you can have your YouTube videos being posted to a website just like this, which I find is really cool. And last but not least, I think my personal favorite has to be this one, the push notification on WhatsApp action. So for example, say you have a corporation or like a small business or something like that, and someone makes a pull request. You can make it so when that pull request has been made and it specifically tags you, then you can get a WhatsApp notification from that pull request, okay? So if you're a workaholic, this might be for you, right? And there are so many things you could possibly do with this. For example, I made a small project where it was for a game where every time enemy ships entered a scanning range, it would send me a text. So there are so many different ways you can use this. And I think along with this, if we head on over to the actual Actions Marketplace, there are so many different categories: API management, chat, code quality, project management. There are a lot. So the GitHub Actions Marketplace is no stranger to pretty much almost anything, which is really cool. Okay, and to finish up really, is this. This is a workflow which I'm certain will not work, but I think it's kind of cool. Yeah, so does anyone have any questions? Yeah.
It's very interesting how you can use it for like so many things, like texting you when an enemy battleship comes in range. Could you do like, can you trigger that from any sort of program process? Like if you had, I don't know, a camera, could you get it to text you if a bird came into shot or something? Or you had a Python script that was...
That's a good question. Honestly, I'm not entirely sure, because I know especially for GitHub Actions, it especially uses GitHub for it. The only way I can really think of, but it doesn't really work for especially your case, would be to run a cron job, and especially kind of like run that constantly to check. But even then, it still wouldn't work out too well, I don't think. So I think for like,
use like another form of automation for that.
yeah, I think, yeah, because GitHub Actions and CI/CD is mostly to work with your own kind of code base. It doesn't integrate too well with, how should I put it, actual software. Yeah, it's mostly there as like you have your software, so what happens after that, right? So you've created it, and the CI/CD is the nice little decoration which makes it that much better. Yeah. Yep.
Tom, you mentioned about the battleships, that usually GitHub Actions get triggered by some sort of event on the repository, but I don't imagine you had a repository for your battleships game. Like, how does that work?
So with GitHub Actions, you can also do cron jobs.
Oh, okay.
And yeah, so Bill, I don't know what cron jobs actually are. Cron jobs can run a piece of code. For example, like after a series of time, they can run it at like 12 AM every single day or every 2 minutes or that sort of thing. And so pretty much I had a workflow which would run a cron job, which would make, I think, an API request, which would do a bunch of other things and check. And at the end of the day, it would send me a text on my phone.
Okay.
Does that make sense?
Yeah, that's kind of
Yeah,
cool.
okay.
It's just weird to have a cron job running on a GitHub action. I didn't know
Yeah.
you could do that. But yeah, it's already hooked up to WhatsApp or whatever, so that's cool.
Yep. Yeah.
What if I'm scared to write unit tests?
What if you're scared to write unit tests? That's a great question, Jimmy. And if you're scared to write unit tests, then maybe CI and CD isn't for you. No, because the thing with unit tests is they're very important. Like, you need it for everything you do. It's the only way to check that what you code actually works. And so it's like the unit tests are the first kind of barrier to make sure things are working. And then CI and CD is just that extra kind of decoration, like I said earlier, to make sure everything's the entire package and all working. Yeah.
Just as a follow-up, I wrote something once that didn't do any testing. It just literally SCP files to a remote server. Yeah, so that was CD without CI. Something like that.
Just a follow-up, UQCS bot currently doesn't have testing on the CI, so...
UQCS bot doesn't have testing?
It tests the build.
Yep.
It doesn't currently run unit tests because...
Well, that's interesting, isn't it? So UQCS bot doesn't have
Well,
unit
actually, technically the UQCS Discord does it, the Slack bot does. But we didn't talk about the Slack bot.
So what I'm hearing is there is a possible opportunity for our UQCS members to go and write unit tests for the Discord bot. That's incredible. And then you can go and add your own testing workflow. Could that possibly be a little bit of a Discord project, huh? I think that'd be very cool. And society would benefit greatly from that. Yes?
I was also wondering, like, how did you learn unit tests? How did you get good at writing unit tests?
Okay, so how did I learn writing unit tests? I think that just comes down to learning the actual, like the package you choose and all that. So I chose PyTest for this because I was familiar with Python and all that. When it comes to actually learning how to write good tests, well, that then comes down to a little bit of like a practice and intuition and that sort of thing. So, like the thing is, for example, you never know what the user is going to type, okay? That you could like ask for an integer and make a type of string, right? But for that whatsoever. They might think that, hey, if you ask for an integer, then the user must always give an integer. But that's not the case. The user might give you a string, the user might give you something null, the user might try to absolutely kind of throw a curveball your way, right? And so with test cases, you kind of learn about what to expect, and kind of, with more practice, you learn and learn and learn until you kind of figure out what's a pretty good kind of foundation.
Right, so like security proofing.
Yeah,
That's more good for the
pretty much. Yeah.
Two questions, and I'm happy to split them up
Okay.
if there's a chance. But with GitHub Actions, can you deploy a specific release? Perhaps if you, it's like you might automatically deploy on push, but then realize it's bad and you want to roll back to a commit or a tag before that, or maybe you are committing to staging first, and then you're happy, like you then manually trigger okay, now have a saved action that lets me hit a button and push it to prod.
So I'm a little bit confused about the question. Can you say it again?
So, like the triggers for GitHub Actions are sort of some, like what we've seen is basically things being pushed mainly to then run a test, or it's pushed into the main branch, you know, might deploy it. But if you've got a scenario where you then want to roll back to a previous deployment because there was something wrong.
Oh, I see what you mean. Okay. Yeah, I mean, I think it's definitely possible. I think, for example, I can't say which corporations exactly, but I know that some, for example, they make a build, they release it to prod, and it's in prod for a while, and if something goes wrong there, then the workflow or whatever they're using, they know that something's gone wrong in prod, and it automatically changes out to a previous release. Now, that there is very complicated, and frankly, I'm like a little bit unsure about how that completely works. But yeah, it is definitely possible if that answers your question. Yeah. Did you have a question?
Yeah. So, how much computing power does GitHub Actions give you? Like, if you run a script and it just infinite loops.
Yeah. So GitHub Actions, I can't remember, but they do give you a free amount of time a month.
I know off the top of my head. It's free if your project is open source altogether. So you can technically run as much as you want until GitHub says no. And then if it's private repo, I think I want to say it's 1800 minutes. But I could be wrong about that. It might be less.
Okay.
But yeah, so basically, projects open source. You can sort of just leave it off GitHub until they kick you.
Yep. Yep.
Yeah, just a follow-up to what Josh was asking before, there's, you can enable like manual triggering of a GitHub action. I think it's like on workflow dispatch. So that there's such thing as an action that doesn't have any auto triggers, but you can, if you know something's gone wrong, you can go into the actions, find it, click it.
Yep, pretty much.
Yeah. Yeah, that's all.
Yeah, okay, sweet. Did you have a question? Yep.
This might be a more general testing question and beyond the scope, but if you've maybe got separate teams writing the code and the tests, and maybe the tests are coming in beforehand, you know, that might be a pull request that fails CI because, you know, the function that it's supposed to test doesn't exist.
Yep.
How do you see that being? I mean, I assume there's a way to resolve it because all these companies are doing it, but...
Yeah, you're right. I'll be honest, even I'm a little bit unsure about how you would resolve it, because like I'm thinking intuitively here, but if you have now tests on the code base which aren't testing anything, then that itself is an issue. So I'm thinking that the actual code has to be on the code base first before any tests could come on. Now, I could be wrong there. So if anyone knows anything else, I'm happy to... Kate, did you know?
You just add tests and code in the same PR. And
Yeah.
fix up the tests that you break in the PR.
Yep.
It's that easy.
Yeah. So adding tests and the code at the same time would pretty much be that. But yeah. Yeah.
So you're just talking about like how you can use it to centralize stuff, like you might push a bunch of code and have a larger central computer compile it. Could you do like a similar thing with, say you were training some sort of machine learning model which needs a bit of compute to do, that you were like doing it on your personal computer, you would make edits to the code, could you like push it up to GitHub and then have another machine, so a beefier machine sort of have its own GitHub actions that get triggered when you push up to the repo, and then it could like pull the code down, train the model, and then push the code back up with the completed model. Could you have something like that?
That is... Okay, so let me just try and understand the question here. So are you...
Push up. And then, so you push up, yeah?
Yeah.
And and then the other machine, it sees the push, and it has a GitHub action that triggers on when someone pushes the repo.
Oh, so are you like asking if there are like different machines which can run the workflow at kind of different?
Well, I assume like GitHub machines would be very powerful,
Yeah.
but you could. I'm just wondering like if this is a possible workflow. Like you have a separate computer that has actions on it that pulls the code when someone else pushes the repo.
I think Jimmy wants to.
You've got two main options you can do here. One, GitHub does allow, it's getting more advanced. GitHub does allow you to let you run, create what's called your own runners. So you can actually run a GitHub action on your own machine. So GitHub will notify that machine to run the thing. So something like that.
Yeah, so
alternatively, yeah, you can do something like that. Alternatively, you can do something like a GitHub action that does push a webhook, but then pushes that to your local server that's listening for that, and then that does the same thing. So yeah, you can do things like that because there's simple GitHub actions that also let you, when you push code, it will automatically style them for you, which do a similar thing. They take your code, they'll run style, and they push the code back. So there's things like that you can do on top of just your general code triggering things. So yeah.
Cool. All right. Any last questions, or is that everyone? Cool. No chat questions? Cool. Thanks, Jack.
All right, let's give Paul a round of applause. Back with standing Tom Malcolm. There's your UQCS mug.
Thank you, Tom Malcolm.
No worries. So, yeah, pizza is on its way. It's somewhere, so we're just going to hang out in here for a little bit. Next Thursday night is industry panel. Yep, so that will be some of our sponsors come in and get to ask questions, and there'll be questions about, yeah, I can't speak, I'm tired. Yeah, if you have, I also currently maintain UQCS bot for Discord. So if you have questions about how the action runs, or how you can get involved doing that, do ping me. I am Jimmy D, so I'm James or Jimmy D on Discord, or come grab me outside. But yeah, all our UQCS, well, most of our UQCS repos are open, so you can see how we do all these actions, and yeah, that's it. So guess we'll just hang out in here for a bit and wait for pizza.
Cool.
Cool.